All right. Well, our next speaker is Alex Tobias from MITRE, and he shared some interesting information with us. So he's from Toronto. He grew up in Toronto, and we've had a number of Canadian folks here. I joke, I grew up in Kalamazoo, Michigan, but my family lived in Detroit, and we'd go to Windsor, and I'm always like, does Windsor count as Canada? And they're like, maybe, begrudgingly, but it's great. You know, grew up in Toronto, went to McGill, got a PhD in chemical engineering from Caltech, and you were in Francis Arnold's group. So those of you who don't know, Francis Arnold is a Nobel laureate. Another synthetic biologist that I work with, a handful of people work there, but Chris Boyd, one of my close collaborators, I don't know if you overlap with him, but so that sounds like you probably have lots of stories from being in her group. That sounds like a really interesting a place to do graduate work. Then was at DuPont R&D in Wilmington, led site lab automation in the facilities there. Also was involved in the U.S. Army Research Lab. So again, a diverse set of experiences involved in automation, looking at a variety of microbial systems. So that's really relevant. And that joined MITRE in 2022 as a principal researcher, and is going to talk to us about the BIONET program. And Alex came to us through a variety of conversations I've had with MITRE recently. One of the folks that he'll no doubt talk about is Mark Sallet, and I've known Mark for a while, and I was really glad that Alex had come and talk about this vision for how we can talk about how labs can be connected, how we might do a lot of the same things we've been talking about, data exchange, standards, and really what I like, and I think you'll see this, I hope, I'm pretty sure we'll see this, is that somebody's really going to put their money where their mouth is and really say, we want to make this effort a reality and have started this, and I'm looking forward to how it develops. So Alex, thank you.
All right, thanks, Doug. You didn't mention the other point I gave, that just about 10 years ago, almost exactly, I hosted you touring my automation lab.
Right.
You were in like a National Academy of Engineering group of young up-and-comers.
Yeah.
And then now, so 10 years
I
later.
didn't want to give my age away.
10 years ago, he was young. Now, 10 years later, the roles have switched, and I've been touring your lab, and I'm working for a federal nonprofit that does work for the federal government. Okay, so this vision for BIONET, which is really Mark Sallet's vision. I'll introduce Mark in a couple more slides, but he's the project leader for this. The vision, starts with the question, imagine if biology was easy to engineer, or let's say a lot easier than it is now. So imagine that anybody could predictably build biological systems. And then, what would it take to get there? And, what Mark believes, and what I believe as well, that it's not just more technology or publications or standard DNA parts for E. coli. We need something more. And the hypothesis for our program is that if we can build a network ecosystem, that we could accelerate the usability and the reusability of biology. So we're talking about pushing for more specialization, pushing for innovation, to be able to tap into innovation coming from anywhere, and for a network, the whole network, to accrete innovations instead of them being locked behind corporate walls, like where I was at DuPont for a while. Not so much exited those walls. And so, as you know, right, the progress of science and technology is like what used to be R&D now becomes routine. There's so many amazing things that are, Illumina sequencing, or even directed evolution of proteins, routine stuff now. And so another way to think about it is like we progress from the working on subsystems, we can perfect those anywhere, and then capitalize on that, on perfecting those subsystems, to now think about higher order systems, make possible what was impossible. And this other visual I made here, I call it the BIONET flywheel. If you look up, you can see like the Netflix flywheel or the Uber flywheel. It's kind of like the virtuous cycle that maybe a company or organization tries to, or is going for, right, where things feed off each other in a cycle. Like, we want more and better ideas to lead to more users of BIONET, to contribute more capabilities, to allow for more innovations, and then more use of biology, and then in a cycle kind of like this. Um, so another way to look at it, you'll see this coming up a few times. Like what we want to do is make possible systems integration for synthetic bio. I mean, that's kind of the promise of the whole standardized parts idea behind SynBio, which I remember in the early days when the term SynBio kind of came up, and most biologists just like they're like, forget it. You know, bio's not like that. It's you can't standardize it. It's idiosyncratic. Um, and I think that it's certainly not going to be easy, or it's not going to be analogous to microchips or software. But I think we can make a lot more progress than where we are now. So this slide is showing. No, I don't even think it's all right, but it's different suppliers, companies that supply parts for the BMW 4 Series, right? You see about 20, 25 different suppliers, different companies making parts for this car. And you can find this similar one for Volvo online or GM cars. So, you know, what we have here is a more mature industry than SynBio. Where BMW, we know the car as a BMW, but they don't build the whole thing themselves. They have all these suppliers of components, and each one excels in their narrow niche, whether it's making the radio or the braking system or the airbags. BMW here, they're acting as the systems integrator, similar to GM, another car company, Apple, Lockheed Martin. They're combining well-described components into novel systems. So imagine we could get to the stage where this was what people did for their SynBio projects. So we'll get to how we think that we can accelerate that in a second. I just needed to, at some point, introduce MITRE and Mark here. So MITRE is a not-for-profit public interest, a not-for-profit company with a public interest charter. There's about 10,000 of us employees. We provide technical and policy guidance mostly to US federal government, perform a lot of independent research, and run 6 federally funded research and development centers, which I've listed here. And anyway, so MITRE is known for systems engineering. MITRE more or less designed what we have as the air traffic control system in this country, missile defense projects, telehealth, cybersecurity, all very core MITRE accomplishments. And so Mark came into MITRE maybe 8 months before I did, after a long career at NIST as federal employee. And he said, I joined MITRE to bring its systems engineering to synthetic biology. So that's sort of part of the connection, where he thought that MITRE would be a great place to make this vision a reality. Okay, so we think about, this is Mark's slide, a canonical synthetic biology project workflow. Right, I've done a lot of synthetic bio projects, and they mostly all have all or some of these elements, right? You've got a concept, something that you want to do. It's make biobutanol from yeast, or make omega-3 fatty acids from Yeroia, or maybe something that doesn't exist yet, like turn sawdust into spider silk. And then you need to have some kind of design, whether it's a metabolic pathway or a protein library. And then you need to translate those designs into the language of DNA somehow. We're calling that compose. And I'm kind of skipping here, or including, I'm including in that, like, the fabricating the DNA. Then you're going to construct some strains, evaluate them, and then if things are going well, you might even graduate things to production. So you have, what we got here, 6, we call these operations. So 6 operations here comprising a workflow. Now, on the opposite end of what I was showing for the BMW, if those are all done in-house, you've got a monolithic workflow. And this is more or less like what we had at DuPont 10 years ago, mostly because we were pretty early to the game, and there wasn't that much of an ecosystem of other companies and vendors that we could tap into. Certainly, we tapped into some consultants and academics, but we were pretty much doing all these ourselves. I worked on biobutanol there. We had 100 people on the biobutanol team. We had everything spanning molecular bio, fermentation to scale up, pilot plant design. So this is expensive, right? 100 people on your biobutanol is expensive. It's expensive in your capital and your operating costs. And it's a challenge to establish and maintain excellence in so many different, competencies or operations. And like I mentioned, your innovations don't tend to be widely disseminated because they're, it's proprietary and considered, part of your advantage, your competitive advantage. So what we're trying to do with the BIONET approach is break up a monolithic style workflow into its constituent operations, disaggregate division of labor, right? Like the BMW. And what we're going to focus on with the BIONET is not what's going on inside each operation. That's mostly, what we've been talking about, this week, and what most companies are doing and innovating, and that's great. We're focusing on the white spaces or the handoffs in between the operations, handoffs or transactions. So we want these transactions, we want to make a network where these transactions can occur in an explicit, well-posed, accurate, low friction way. So we're going to focus on what's required from each operation. Like, what does each operator need to know and need to have to do the job and meet the requirements of the customer? So we've got, input specifications, input materials, maybe input data going into an operation, and then that operation is going to occur, and it can kind of occur from the BIONET's perspective, not really concerned with how it's happening, right? You have some new technology to make DNA or to miniaturize assays, or miniaturize fermenters. That's amazing, and you don't need to disclose that. When that's operations done, BIONET's going to expect, your customers are going to expect, the output specifications and whatever materials, if materials are generated, and the data, right? So we're not focused on the how, but it's the white spaces in between. And so, what we're looking for is a BIONET that we say, distributed innovation and resilience. So for all these operations, there's going to be multiple operators on the BIONET, for each offering their flavor of the operation, or each competing or just in different parts of the world. But as a customer with a concept going into this network, you'll have a number of choices, and it could be based on who's available at the time that you need that service done, or the trade-off between price, quality, and time. But this competition and this disaggregation and specialization, this is what we think makes for a healthy, resilient, bioeconomy. As well, there's this famous business quote, Joy's Law: no matter who you are, most of the smartest people work for someone else. This is right, kind of like we had 100 people on DuPont and biobutanol, and we had a lot of great people, but like, did we have the very best people, and did we have the very most diversity of approaches in that team? Probably not. Probably not compared to, if there was at that time a vibrant ecosystem of all these different things. Wouldn't it have been great to get, a whole bunch more designs, pathway designs from diverse parts of the world and diverse education and experience to compare with the designs that we came up with? And maybe some of those designs would have had elements or the whole thing that would have been very useful. Here, just showing, I spent a lot of the past year kind of hypothesizing or iterating on diagrams kind of like this, like how much ground do these cover? So thinking about the products of SynBio workflows, which are usually either a protein, including an enzyme, or a small molecule, right, like a butanol or a carotenoid that I worked on ages ago, or the engineered organism itself might be the product, right? Like thinking about the Pivot Bio or something, the engineered soil organisms for nitrogen fixation. So here, I mean, we're still, these are the operations, the black squares, and we've kind of just grouped those into, you might call them elements here. And so we've got about, I think, 10 or 12 operations here. And again, they won't all be in every workflow. But at this point, we think that this is going to cover most of the ground for the workflows that we're concerned about. And so, this is kind of the basis that we're building uh, the operations and the sub operations, most of the specifications on the BIONET. So I made this slide to directly connect to the BMW slide, right? So what we want is, if you the systems integrator, and this could just be an average person, or it could be one of you, a customer, someone with an idea and funding to get something done in synthetic bio. So, we have it as, to act as a systems integrator, like the BMW, or if you're not as sophisticated, to, act on behalf of somebody, the integrator acting on behalf of somebody, like their agent on the BIONET. So using the BIONET to interface with these different, in this case, for example, companies that are, the suppliers or the operators for your project. So I just, invented some names, some supplier names that, maybe have a little similarity to some other companies that we've heard of. But right, so for example, here, right, we've got this project is you're basically outsourcing, right? Design and compose and build and express and evaluate. And and so in that way, you didn't need to start your own company and hire all these people and maybe keep them on the payroll all year if you didn't really need that. And you'll probably be able to access the very best of the best at this time, and not have to be an expert in all these operations. And you don't, and so that's what we see as the future of this business. Just like other industries have sort of disaggregated, with even without an auto net or a airplane net, that happened naturally, just as economics and the forces of efficiency you know push things in that direction. This is just getting into a little bit more detail about like the operations on the BIONET. We want to say they're extensive. They're going to be extensive and extensible. So we want the operations. There's just a little small here. Like we want people to be able to go on BIONET and discover, right? Like search and browse, like other online marketplaces, for operators that can do the kind of work they need, or to even help them compose the workflow or compose it on the BIONET themselves with programmable tools to compose the workflow and sort of populate it with the vendors that you end up selecting. If you're an operator, we want you to go on and go through our extensive list of operations and compose, put them together, what you specialize in, right? So Damp Lab, listed 40 or so things yesterday. So Damp Lab would go on and find the descriptions that apply to all the things they're good at or that they're willing to do for people who find them on the BIONET, and list them. So list them for their own profile. So we're going to have, a controlled vocabulary for standard description of these things. So we're all speaking the same language. And then this vocabulary and these operation libraries will be maintained by what we call a BIONET alliance. We'll describe that a bit later also. And the plan is for this to be also open source and to have lots of contributions, like contributions of operations that maybe as technology progresses, new things come about, or plugins, various plugins that would make doing certain things on the BIONET easier or have value. And this just drills down like one more step, just to give you a little flavor for if this operation, right, transforming an organism with DNA. Most of us are familiar with that, right? If you think about like what if you're going to have someone else do that for you, what would you need to tell them? What do they need to know in order to do that for you, right? So they're going to need to know like the chassis organism, what it is, or where they can get it, or you're going to have to send it to them. Something about the DNA, like at least their concentrations might be important. And the selection marker, like they're going to plate things out, they need to do it with the right plates. But there's certain things they don't need to know, right? They probably don't need to know like everything that is on your plasmid. I mean, they need to know the safety aspects of it. But yeah, they may not need to. They don't necessarily need to know everything about what you're having them do, every detail. And then when they're done, right, what they're going to return a number of specifications, just three of them here, right? Like, you know, what are the names of these organisms? And, you know, either maybe you provided them the names, but like, you know, they're going to need to give you a map of like what's where, you know, in the samples with the labeling, right? What's in the wells or what's in the tubes. You know, if the biosafety level changed, um, then they, you know, they're going to provide this, and that might just be sort of a flow through if they don't exactly know. I mean, again, they have the right to know the safety of what they're dealing with, but if they started with like a BSL-1 organism, and but then the plasmid had something on it that made the transformed organism like a BSL-2, then you know they need to know that, and they can send that back. And again, because these outputs might end up going to the next provider on the chain, right? This info might go through the systems integrator, but it might just be passing along through over to the next person, say, doing assays. And then, you know, basic things like what's the shipment information if these organisms are being shipped, and where are they going? Okay, so this is a slide about what kind of content the BIONET's going to have. And so things are going to be object oriented, and that's going to support programmability, digital twins, and systems integration. I'm not a computer science guy. I don't fully get the whole concept of it, but I know it's like it allows for like validation of like what fits the requirements for a certain field, for example. So you know it supports some certain machine readability and automation. That's partly why we call it a programmable access or programmable BIONET. That you know, systems integrators can write some code to automate some things that that they might want to automate, or people could write plugins to, you know, if complicated data sets are coming in, write a plugin to help the systems integrator visualize that data very quickly. So we're going to have, you know, content to compose workflows, right? Like organizations like Damp Lab and then their operations libraries. We're going to have tools like API libraries for interfacing. A big part of what we're talking about is MITRE is going to be doing what we call reference implementations. But MITRE is not going to build, you know, everything. Like we expect whatever MITRE puts out in, you know, a year or two, the community would probably contribute, you know, 10 to 100x more. There's going to be, you know, we'd like it to have dashboards, or people could write plugins that provide dashboards, a dashboard for a systems integrator to track all the projects they're involved with. Certainly a dashboard for operators to track all the jobs they're responsible for fulfilling, workflow status. And then, you know, for transactions, we're looking at some Web3 technologies. We have two Web3 software engineers on our team working on something called Fair Exchange Protocol. It's basically like an escrow system using Web3 for payments to ensure that, you know, the payment is only fully processed when the job is complete and fulfilled. And, you know, mechanisms for negotiating back and forth to agree on the scope of work. Those are a lot of the content that we're planning for. So we're currently in what we call alpha phase of BIONET. We're building and testing components of it. We've finished what we called alpha.0, which was MITRE internal demonstration projects using, you know, our own laboratory staff, where we you know, wrote specifications and protocols for some pretty simple synbio workflows, basically getting some plasmids on AdGene and then transforming them into E. coli, and, you know, quantifying fluorescent protein or carotenoid, or doing a sense and respond circuit or sense and respond switch. And so, you know, this exercise helped us build up already a pretty big library of specifications for the operations, about 5 or 6 operations that we perform there. We're in the middle of alpha.1 now with an academic team doing a protein engineering project. So we're not running the project for them, but we're they're helping us document the project to even further refine our specifications. Soon we're looking at Alpha.2 with global biofoundries in the GBA, including Damp Lab. So kind of scaling things up, looking at how the GBA could work together across laboratories, um, and help, again, provide feedback for the various tools and handoffs and specifications. Are they complete and sufficient? How, does this concept actually work across, geography? We also have involvement with an undergraduate class to sort of get them to play the role of systems integrator, get them thinking on that higher level of not just the subsystems, but the higher level systems. And then, down in the next year or two, looking at sponsoring and working with one or more iGEM teams and what we call refactoring an existing foundry. And maybe that would end up being Damp Lab. And so, I mentioned BIONET Alliance. Like the plan is that MITRE to prototype or build a reference BIONET and fledge it to a new nonprofit entity that we'll call the BIONET Alliance. And this will be composed of members from the global SynBio community, early adopters, innovators, and we may have it use another like Web3 technology for DAOs, distributed autonomous organization for voting and making decisions. So the alliance would be the governing body that would say approve plugins or new operations. Every system like this needs like some governance and management, right? So and it would have to pay for itself. So some kind of a business model, probably a small portion of transactions conducted, a bit like the way eBay does it. And make decisions on change additions to the ontology, or if changes to standards need to be made. And so this is the vision that like MITRE is going to design and fledge this, but ultimately not be the one like controlling it all. So we recognize but the BIONET will be no fun without BIONETers. So we need to build something that people are going to want and want to use, that's going to benefit them in their projects, that they can trust, certainly, and that's extensible. And we're already excited about what kind of add-ons and directions that the community is going to take this. So just a summary of what I presented, that we're prototyping a BIONET ecosystem. It's focused on the handoffs between operations. We're seeding reference content that we want to be extended by the community. The vision is to unite capabilities in a connected network, foster innovation and resilience for economic development, and to get to that disaggregated state that other more mature industries have already reached, and to democratize access to biology. So especially if you think about like the design step, that often just takes a person with experience and education and a laptop, and they could be anywhere. So I'm pretty excited about that step being pretty easy to get on the BIONET, and probably pretty inexpensive for people to solicit designs for their vision, for their concept from all kinds of folks they never would have thought of, never would have realized were out there, and to get back some, in many cases, really useful, innovative designs. Right, or also make the BIONET a tool for solving problems in a local way, right? Solving problems from a local scale to a global scale. But we want to make solving hard problems possible by applying systems integration to biology. And I mentioned the BIONET Alliance. And I think that brings me to the end of my presentation.
There are some, so this vision is a very disaggregated sort of idea. Some companies are sort of taking the opposite approach, to be able to do everything, scale it up as much as possible, and sort of put the idea that they can be providers world needs or something. What are, I mean, you've talked about a lot of the pros of this, but do you think there are benefits or drawbacks to something like that? This way of doing it?
I mean, I think that we wish everybody success, however they can get to it. I think what we've observed from that model, right? It's expensive. It requires a lot of investment, right? I mean, especially right now, we're in a time where that investment is harder to come by. And so, yeah, so we just want to provide an alternative to that. But we've already gotten some interest from at least one of those bigger fully integrated or mostly integrated companies, and they probably have a lot to contribute.
That was going to be my follow-up.
Yeah.
Like, how would those they fit into companies like that do several of these steps before handing it off?
I think some of them realize that not all of their customers or potential customers actually want like the whole set of offerings that they've got. So they want to maybe open if they have extra capacity unused that they've invested a lot, that it's better to have customers using like parts of that capacity than to leave it. So I think that's perhaps why some of those are interested as well, getting themselves listed on the BIONET. And certainly I think BIONET could benefit from a lot of the work they've done or the software development that they've maybe done for their own in-house white spaces that we might be able to benefit from. Yeah, good question. Yeah.
You mentioned open source. Is there a repository that we can look at that's underway?
Things are underway. I don't think there's much to look at. It might be possible. I think the Web3 has some kind of a GitHub that I don't know that it would be too exciting to see yet, but yeah, within a year, yeah.
Okay.
I think there'll be a lot more of that.
Okay, sounds good. Thank you.
When it comes to ontologies, are you aligning with
I'm not personally, I don't think I'm familiar with that one.
yeah, check it out because
Okay. How do you spell it? A-E-L or allotrope? Yeah, thank you. I mean, yeah, we don't want to be like just another set of standards for things, right? So yeah, we want to like incorporate all the best available standards, and certainly BIONET Alliance is likely to be composed of a lot of folks from behind standards, and Mark Salad is a standards guy. So yeah, we're looking. I mean, I think we're looking for, or I don't understand it so well, but you can have an ontology, which is, to my understanding, it's like kind of like a dictionary or vocabulary, but also more of concepts that are connected and what are the relationships, and you can have like the software kind of ingest all those relationships, and that can become part of the network architecture. So yeah, we don't want to do it just on our own. If there's something good out there, yeah. Thank you.